Looking at more questions as examples, and this will be example number 2, and this involves equations with roots, right? So here we have 3 into root of x plus 4 minus x. The moment you see this, you can clearly see, according to the overall quadratic strategy, is I don't have any fractions involved, and that's a good thing. So now I'm going to go to the next part and see, do I have any roots involved? Clearly we see this 3 multiplied by square root of x plus 4 minus x is equal to 0, and I'm going to look at that now, and I want you to see this. This is 3 actually multiplied by root x plus 4. Okay, now if I had to say that's a multiplied by b, in other words, I've got one term or one factor multiplied by another factor, then 3 would be considered my a value and this will be considered my b value. Okay, so let's go back to this and let's look at the strategy when we have equations with roots. The first thing to do is to isolate the root, and isolate means we want this thing all on its own, right? So I've got 3 multiplied by root of x plus 4 is equal to, that thing can go over to the other side, or I can just add x to both sides of the equation, and that's what it yields, right? Now the next very important thing is to square both sides, right? So I'm going to square this term, and remember what you see in blue here, that's what I'm going to use later on to check my answer. But I'm going to square both sides. When I square that, and I square this, right? Okay, so what's that going to look like? Okay, so I just want to go to the next page and show you something quickly. There's a law that says if I raise this to a certain power, if I have a times b raised to the power of n, that's going to be a to the power of n multiplied by b to the power of n. So if I look at this specific thing over here, it's going to be 3 multiplied by root x plus 4 raised to the power of 2. Okay, that means I'm going to take each of my factors. The first one's going to be 3. I'm going to raise that to the power of 2. Then I'm going to take root of x plus 4. I'm going to raise that to the power of 2. When I do this, 3 squared, or 3 times 3, is 9. And this thing over here is simply multiplied by that whole thing. The root and the square, they cancel each other out, and I've got 9 into x plus 4. So this is a very important thing to note, because some of the students are unsure as to what to square. Sometimes they let the 3 fall away completely, but be wary that you shouldn't, right? Okay, remember, I'm not writing for nothing. You should be writing with me because you want to engrave a neural pattern. So when I square both sides, I square the 3 and I end up with that 3, oops, not there, and I end up with x plus 4 on this side is equal to x squared. Okay, now let's distribute that into it. I've got 9 times x is 9x plus 36 is equal to x squared. Let's get all the x's on one side. I'm going to go with a positive x squared. I'm going to bring over this 9 and I get 9 minus 9x. I don't know what's happening with my pad over here. Minus 36 is equal to 0. So now I've got it in the standard form of a quadratic equation, ax squared plus bx plus c, and I'm going to read this mathematically. That says I am looking for factors of 36 that I must minus to give me 9, and that's truly 12 and 3. So I'm going to put x in there and an x in there. I've got 12 and I have 3, and the minus sign indicates that I'm going to have two different signs in here, and the bigger number will get the sign of the middle term, which is negative. Okay, so therefore this implies that x is equal to negative 3 or x equals positive 12. Okay, now we are not completely done, because we need to check the solution, and we're going to write down this equation. This was 3 into root of x plus 4, right, is equal to x, right, before we squared it, because these are valid solutions to this squared version over here, but we were not given the squared version and we have to check it according to the original equation. So I'm going to substitute in the values there. If I put in negative 3, I'm just going to draw a line down there. I'm going to put in 3 into negative 3 plus 4, and that's going to give me, okay, 3 multiplied by square root of 1, which is just 3. Then I'm going to put in the negative 3 on this side into the x, and that just gives me negative 3. So here you can clearly see I've got 3 is equal to negative 3, and that tells me that the negative 3 is not valid as a solution. Okay. Now I'm going to check the value of 12. So I have 3 multiplied by 12. This takes the place of the x, plus 4, right, is equal to, let's just put it into the other side. I'm going to simplify this. 12 plus 4 is 16, and square root of 16 is 4, so that's equal to 3 times by 4, which is simply equal to 12. And then if I take that 12, right, and I put it into x on this side, I get 12. So now you can see when I do my check, I've got exactly the same thing on both sides. That is correct and that is correct. Okay, and that's example number 2.